Hey, it's Mr. Donahue again. This time, we're going to take a look at naming acids and esters. All right, so these are going to be a little different. I know this has been our system, but it's going to be kind of the same, but kind of different. So you find the longest continuous chain, you number the carbons so that if there's a substituent or functional group, it's given the lowest possible number. And then you name and give the location of each substituent groups. If you got multiple substituent groups that are the same, then you use ditri, etc. to say how many of them you got. So you got two chlorines, it would be dichloro. And then if you got different ones, then you list them alphabetically. Okay, so carboxylic acids. How do we name these things? Well, base and then suffix, except this time the suffix is going to be anoic acid. And the base, again, is just telling you how many carbons you got. So things like butanoic acid would be the name for a carboxylic acid. You don't need a number for saying where it is because there's only one place that the carboxylic acid group can be, and it's on a terminal carbon. So you don't need numbers with these ones. So again, find the longest chain, 3 carbons. So how do I say 3 carbons? I say prop, all single bonded. So it's just propanoic acid. And that's how you name it. That's propanoic acid. What about this one? All right, well, this one has 1, 2, 3, 4 carbons. So this would be butanoic acid. All right, bring on the next one. Okay, this one's a little uglier. So COOH, that is telling me I got a C double bond OH, so that's how I know it is a carboxylic acid. I count the carbons. How many do I got? I got 6 carbons, so that tells me it's hex. And then anoic acid because it is a carboxylic acid. What if I had octanoic acid? Well, oct tells me I have 8 carbons. So 1, 2, 3, 4, 5, 6, 7, 8. And then on that carbon, you got the O with the H right there. So that is octanoic acid. There you go. All right, esters are probably the most interesting things that you got to name. It can be the trickiest. Basically, it looks like you got an alkyl group. So you go like alkyl group, and then it looks like an alkyl group that has a double bonded O on it is going to get the O8 ending. So the side with the double bond O gets the O8 ending. That's how I remember it, because the O, like this oxygen right here, splits it into like 2 chains, and the side that gets the double bond O gets the O8 ending. That's how I remember it. And the other one gets a YL ending, so like methyl, ethyl, etc. So methyl butanoate will be like how you name it. So the alkyl group goes first, and then it ends in whatever the O8 part is. So let's name this thing. All right, well, I see that I got an ester because of double bond O and the O in the middle of 2 carbon chains. So I'm going to split it in half at that ether looking oxygen. Boom. So I'm going to look at it as 2 different halves. And I'm going to start with the half that doesn't have the double bond O. So I'm looking right here. There are 2 carbons. So how do I say there are 2 carbons? Ethyl. So I got ethyl. And then over here I have 1, 2, 3. That's a 3, 4 carbons. So I'm going to say but. And then the suffix for this one would be anoate. So this is ethyl butanoate. So that's how you name that guy. Give me another one. Give me another one. Okay, again, I know that I have an ester because of the C double bond O and the O in the middle of a carbon chain. And I'm going to split it right there at that ether looking oxygen. And I'm going to treat each half as being like alkyl groups. So I'm going to start with the side that doesn't have the double bond O. And that's just 1 carbon, so I'm going to get methyl. And now I look at the other half that has a double bond O because that's going to get the O8 ending. And again, it's just 1 carbon, so it would be meth and O8. So this will be methyl methanoate. What about this one? This one I might want to draw out a little bit. I got a CH3, I got a C, double bond O, and then an O, and a CH2, and a CH3. So again, I know it's an ester because of that double bond O and that O in the middle of the carbon chain. Split it right there, treat it as 2 different things. I'm going to start with the part that doesn't have the double bond O, 2 carbons, so that'll be ethyl. And then I look at this side with 2 carbons, that'll be ethanoate. So this is ethyl ethanoate. Pleased to meet you. All right, how do I draw hexyl butanoate? All right, well, hex is telling me 6. So I got to draw 6 carbons. 1, 2, 3, 4, 5, 6. I counted that right. And then, all right, well, the this is an ester, so I know there's going to be, whoops, an oxygen after that 6 carbon. So 1, 2, 3, 4, 5, 6, and then an oxygen. And on that, off of that oxygen is going to be another carbon that's going to have a double bond O. And then the butanoate is telling me that there are 4 carbons. So here's 1, 2, 3, 4. So now that is my hexyl butanoate. And that's carboxylic acids and esters. So I hope you found that helpful and see you in class. I'll have practice problems for you. So yeah, bye.